Okay, guys, take day 2 of ratio tables. I'm going to kind of focus on more of like how standardized testing would be, since we're kind of transitioning into online. Well, most of the time, they're already going to have some graph for you versus you graphing it. So let's look at this one here. It says, in a field of flowers, there are 200 tulips and daffodil bulbs. For every one daffodil, there are 3 tulips. Which coordinate plane shows a point that represents the number of, versus this is my way, number of daffodil bulbs and the number of tulip bulbs in the field? Okay, so let's look at this. Here is the important part. For every one daffodil, there are 12 tulips. So let's write that as a ratio. One daffodil for every 3 tulips. So we want to know which one is the same exact ratio by looking at the coordinates here. So let's look at the first one. In A, number of daffodils is 125. So this is 125 to 75. So this would be 125 daffodils to 75 tulips. That is not going to be the answer because I have 1 to 3, and this is, believe it or not, you divide this by quarters, right? How many quarters make 75 cents? That's 3. How many quarters make $1.25? That would be 4 plus 1 more, which is, what did I just say? 5. This ratio is 5 to 3. I want 1 to 3. So A is not the answer. So you do it again. This says number of daffodils is 75 to 125. 75 to 125. Let's divide it by quarters. Divided by 25 cents, divided by 25 cents. 75 cut into quarters gives me 3 quarters. $1.25 divided by quarters, I have 5 of them. Again, not 1 to 3. Closer, but not it, not B. So it has to be either C or D. So let's just go in order. Let's try C. Yes, you would have to do this for each of them. That's a good strategy because we talk about finding the best way to do these. So this saying 150 daffodils to 50. You should tell me no. Because if I divide this by quarters, I get 2. If I divide this by quarters, I get 6, which would be, then I cut this in half, and then I cut this in half, and I get 3. I'm sorry, I get 1, 2, 3. I want 3 to 1. So, not this one. So this last one that I have hiding is the correct one. Let's prove it. Number of daffodils is 50 to 150. If I divide both of these by 50, you get 1 to 3. So the correct answer is D. Order does matter. I wanted daffodils to tulips. So I had to make sure it was going in the right order. Okay, next one. Let's look at this. You always have to kind of read the title and kind of work from there. The tomato juice is sold in a case of 8 cans. Complete the table. Okay, number of cases, number of cans. So a case is 8 cans. So one case would be 8 cans. How many cases would I have if I had 32 cans? On this? Would it be 4? Yes. If I have 10 cases, how many cans would that be? 8, correct. And then if I have 96 cans, how many cases would that be? 12. How do I get those answers as well? If I go 1 case is 8, I'm multiplying by 8 if I go forward, right? And then if I'm going the opposite direction, which is the inverse, I'm really dividing by 8. 32 divided by 8 gives me 4. 96 divided by 8 gives me 12. So there you go, I'm filling in the chart. Okay? All right, so all of those should be the same ratios as well. Look at this one. There are 24 students for every 2 teachers. That sounds about accurate for this year, not in a normal year for a field trip. Okay, but let's say for a classroom now. Complete the table. Well, I gave you a hint. Find the unit rate. How many kids are there for a teacher on this field trip? That is your unit rate. So I want to know, if I have 1 teacher, how many students would that be? Well, if I have 24 kids for 2 teachers, what would it be for one of us? Well, hopefully you can take 24 and divide it into 2 and you get 12 kids. That's the unit rate, by the way. So then therefore, 1 teacher would be 12. So really, going this way, I'm multiplying by 12. So to get this answer here, I would multiply by 12. 7 teachers times 12 would give me 84 kids. Okay. Now, what if we have 60 kids that need to go on the field trip? How many teachers do we need? Well, we got to do the inverse. So I'm going to take 60 and I'm going to do the opposite, or you can think about what times 12 would give me 60. Either way, it doesn't matter. If I take 60 and divide it into 12 pieces, I need 5 teachers to go on the field trip. Again, the same idea here. If I take 156 and split it between 12 groups, how many teachers do I need? Well, in this case, you might have to do long division. Does not hurt. That would be 12, which gives you 36, which would be 3. So it would be 13 teachers. So it's all about, the best way to do this is figure out what is the pattern that you're seeing. What's the unit rate? What's the relationship between my X to my Y? What's the relationship between your input and your output? Okay. Now, this one, I don't have any words. It just says complete the table. So we got to figure out weeks to allowance. And the only thing I know both of is right here. So 3 weeks, I make $21 in my allowance. What's the relationship between the two? Well, remember, this is your X, this is your Y. Ooh, this is talking about money. So let's see how much money I make in 1 week. So remember, money goes on top, or some of you already see this, but it would be $21 for 3 weeks. I want to know, what am I going to make in 1 week? That's basically what I'm doing to go forward. Hopefully you can see that without actually, doing what I wrote down here. It's $7 a week. Okay? So I just found the answer to the first one. From here to here would be times 7. From here to here would be times 7. So 1 week I make $7. 9 weeks times $7 a week, that would give me $63. The only one I have to do is go backwards on the 49. So we do the inverse. What times 7 is 49, or 49 divided by 7 is what? 47. There you go. Do the inverse. Inverse. Those are inverse operations. Inverse operations. Inverse. Okay. All right, same concept. This time I actually have some information. There are 20 small panes of glass in 5 windows. So a pane of glass is like, well, let's figure out what the rate is, okay? Fill in the table. How many small panes are there? Not panes for a window. It's like sections of the window in 1 window. Well, 20 small panes in 5 windows. I want to know how many in for 1. So you're basically taking your panes and dividing it by your windows. So you have 4 panes in 1 window. So this would be 4. So this actually is dividing, right? I'm going backwards. I'm going from 4 and I need to get to 1. Okay? It's not subtraction, so hopefully you realize that it is not subtract that amount. So have you ever seen a window and then it has, sometimes people have like these little like plastic white pieces going through it? This is a pane, that's a pane, that's a pane, that's a pane in one window. That's what that means. Okay? So if you notice, 4 going to 1, or you can think about it going this way, whatever works best for you. I'm dividing it by 4. Or I can think about it multiplying by 4 this way. So what would be 8 cut into 4? How many windows would I have? I would have 2 windows. Okay? If I had 20 panes, so 20 little boxes, those little things that I have the dots around, how many windows would I have there? Well, if I divide that into 4, because there's 4 per window, I would have 5. 28 would be 7. So how do I go the other way? I have 4 windows, and there's 4 panes per window. So you're actually doing the inverse now, which is multiply by 4, which is 16. So what is the ratio? The ratio is 4 to 1, or 4 over 1, or 4 to 1. And how could I explain the meaning of my ratio? For every 4 panes, small panes, it makes 1 window, or it'll make a window for 1 window. Okay. All right, here's another way to show it. It's just now not across, it's now looking at this. This is called a ratio table, or you can call it whatever you want. So we got to figure out what is the relationship between dollars and hours. So this is this. This is this. So where do you need to start? Well, you should look right here and go, oh, this is important, right here. So what goes on top? Money, right? So I am making $90 in 5 hours. So I gotta figure out what's the relationship between the two. So let's figure out the rate. Let's figure out how much money I'm making in an hour. So if I take 90 and cut it into 5 hours, let's see if I'm making good moolah here. Well, we're in the $10 range. 40, $18 an hour. That's fantastic. So you could do it 2 ways. You could go from 5 times 18 to go to 90, or you can do the inverse. I kind of like going this way. So 1 hour, I make $18. 5 makes 90. If I do 12 times my $18, how much would I make? So 12 times 18. 16, 36, out of there, that would be 8 and 1. $216 in 12 hours. So then how do I go the other way? Well, you could think about what times 18 is 180, or you could divide by 18, which hopefully you can kind of see that that is 10 hours. So if I ask you to fill it in, you don't have to tell me the unit rate, but you should. That's the strategy. Figure out what it is for 1 hour or 1 item. Okay, looking at this, Zoe, because that's my little dog's name. Zoe is reading books. Apparently my dog's reading. For a reading contest, she reads the same number of pages each hour. So the same rate, constant rate. Constant rate means that we're going to have a straight line, which we call linear, right? So what is the unit rate based on this picture? So she reads the same number of pages for each hour. So we want pages per hour. So let's let's look at here. Okay, this would be 2 hours, she read 40 pages. This one says 4 hours, she read 80 pages. So we have two of them, they better be the same answer. So 40 pages is in 2. What would she read in 1? That should be the same answer if I do 80 pages in, was it 4 hours? Again, where am I getting this information? This says pages, this says hours, so I gotta make sure I put the right number in the right spot, right? How do I know this is the right order? Because it says it in the sentence up here. Pages for each hour. So what do you get? Do you get the same answer? Because you should. Half of 40 is 20 pages an hour. 80 divided by 4 is also 20 pages an hour. That proves that she's reading the same amount, same rate. Okay? If she's not spending any time reading, then she's not reading anything. Okay? So there's your linear that proves that it is linear. So just adding this, how long in hours would it take Zoe to read 60 pages? So you could use the graph if you'd like. So if she wants to read 60, where would it hit the line at? Now you can look at it that way, or you can look at what we know. Okay? We know 20 pages she can read in 1 hour. I want to know, in hours, she's going to read 60 pages. This is 60 pages. That would go on top, not on bottom, so this would be 60. Well, then how do you go from there? You can do a couple of different ways. You can make it into a chart or whatever, but how do you go from 20 to 60? You say add 40, no, think about multiplier, divide. If you think times 3, that should make sense. Times 3 would be 3 hours. So the answer here is 3 hours to read that. If you look right here would be 3, and that's where it kind of intersects on that line. 3 hours. I have kids do this also too. They go 1 was 20, 2 was 40, so 3 would be 60, and then 4 would be 80. Could you do it like that? Absolutely, absolutely. Either way, it doesn't matter. All right. This was an error question. It just kind of had you, again, filling in the ratio table. This says it has a ratio of 1 pound of cement is 3 pounds of sand. So looking at the relationship between the two. So what would be 2 pounds of cement? Well, 3 plus 3 would give me 6. So times 3 times 3. So what times 3 would be 12? Or do the inverse, that would be 4. And then what times 9 times 3 would give me then 27. So again, that's another one where you had to read the information at the top. Now again, if you look at it, the ratio weight of cement, so here's that cement, to the weight of sand, there it is. That's why this says 1 to 3 right here. Cement, sand. Order matters. Okay. And this will be the last one. We got to pick the right graph. So it says it takes an artist 1 hour to frame 3 paintings. Which graph represents this? Okay, so we want 1 hour. So here's the number of hours, has to be 3. So is this at 1, 3? No. Is this at 1 hour is 3 paintings? Yes. Let me prove to you the other ones are not true. This one says number of hours, 1 is 2. And then this one says number of hours, and that says here. So, oh wait, I got 2 answers. I can't have 2. So don't do what I just did, because we've got to look at it past that amount. So if 1 hour is 3 paintings, what would be 2 hours? 6, right? Is this at 2, 6? Oh, yes it is. Is this at 2.6? No, it isn't. So this one is not the right one. It's that one. Okay. All right. So I went over a couple examples. This is day 2. So make sure you do day 2 of ratio tables, and I will see you tomorrow.